This is Conceptuality6 video to go along with the writing. We're going to talk about the volume, the containment of these self-organizing structures. Okay, we know it's really simple to understand the tetrahedron. The AB tetrahedron contains one volume of space, one tetrahedral volume of space. Okay, it's straightforward, simple, and easy. Okay. Now, what does the AB length? What's the volume of the AB length octahedron? Well, it's really here's one way to show you, and then I'm going to have to prove it to you in another way. But this is I can take this octahedron, take any point of it, right, and push it down, and now we have a half octahedron, right? So here it is, right? Half octahedron. Looks like the pyramid of Giza. Okay. Now that unfortunately is no longer stable because we have a square unstabilized open face here. Now, if we take an AB length, got one here, all right, and put it across this open space. We have, an AB here, right? And we put it across this open space and make it exactly that length. We squeeze, in other words, we have the octahedron square face and we squeeze it down until it's exactly the AB length. And then we have two tetrahedrons, right? There they are. They're face to face. They're face bonded tetrahedrons. Open it back up, and we have our half octahedron. Now that intuitively tells you a pretty good clue that that half of an octahedron contains two one-unit tetrahedrons. You might question it a little bit because you'd say, gee, this has more volume, obviously, than two tetrahedrons, and as it squeezes down, it must have less, and then if you go like this, it'll squeeze down to no volume at all. But at the exact length of AB, then you have two identical tetrahedrons, and it implies that a half an octahedron contains two tetrahedrons. And in fact, it does. The tetrahedral volume of an octahedron is 4. Now, this was an intuitive way to see it. Here's the mathematical way to see it. Here's our octahedron. We've divided it into 4 sections. This one section is 1/4, right? So you can see that there are 3 more sections. Pull this thing out. And what is it? Well, it's a tetrahedron. 1, 2, 3, 4 points. 1, 2, 3, 4 faces, right? It's just a tetrahedron that is a different shape, but it has exactly the 1 unit base. This is 1, 1, 1, so it has a triangular base of 1 unit, and it has the same exact height as the tetrahedron, right? You can see if you put the octahedron here against the tetrahedron here, you have the exact same height, right? It's intuitive and it's a fact. Okay. So this tetrahedron, this 1/4 octahedron is exactly the same volume as this 1 unit tetrahedron because they have the same base and they have the same height. And area of base times height divided by 3 is the volume of any tetrahedron. So these have exactly the same description. It has exactly the same base, it has exactly the same height, so it has exactly the same volume. And that's so we have proven that the 1 unit octahedron contains 4 one tetrahedron volumes, and that's awesome. I mean, it's really an amazing thing that this universe is self-constructs in completely whole and rational ways. Um, I think that it's just inspiring. It's amazing to see these things. You know? So now we can see in the two frequency tetrahedron. You know, here it is, one, two, two frequency, which contains the octahedron. We now can just see the volume of it. We know that the octahedron is 4, and we've got 5, 6, 7, 8. You know, there's four tetrahedrons on 4 of the 8 faces of the octahedron, involved in a two frequency tetrahedron. So 2 to the third power is 8. So that it's all completely, completely whole and rational to figure to know the volume of any frequency of tetrahedron. You just take it to the third power. So that's it's completely consistent in and understandable and rational, wholly rational. That's the point. That we finally got to the point. Okay, we have area and volume covered. Area is frequency squared. Volume is frequency to the third power. All right, that's it.